So, what we're going to do is we're going to solve these absolute value equations that we've been looking at, but we're going to do them graphically. Again, we're going to do it graphically. And it actually is a lot easier. And once you think about the technique, when you do this enough times, it's very, very simple. So the first thing, you don't have to write all this down, guys. You don't have to write this down. We're going to just read it. So we've thought of absolute value as the distance between a given coordinate and 0 on the number line. That's our definition. But we can also say that the distance between some numbers a and b on the number line is the absolute value of a minus b, or the absolute value of b minus a. Because it doesn't matter. If you flip the sign here, we know subtraction is not commutative, but either way, you'll get some, say you get a value of 5 here. Say this turns out to be like, let's say a is 7 and b is 2. That's just 5, right? But here, if you did it this way, you're going to get negative 5, but it's still just 5. So these terms are interchangeable. That's the first thing we want to note. Okay? So that's the one thing you might want to write down. That absolute value of a minus b or the absolute value of b minus a are the same thing. Okay? The same thing. And the last thing is also important. It's going to come up. Notice that when we are representing the distance, we use a minus sign. Whenever you're looking at distance, and we did that earlier in section 1, or chapter 1, when you were searching for a point that was 1/3 the distance of a that it was from b, and we did like d1 equals x minus 7, d2 equals 12 minus x. We looked at the distance between points in the number line, and it was always subtraction. Okay? So, with this said, let's get into our examples. The examples will make this very simple. Okay, let's look at the first one. And I'm going to step you through how to do the first one, and then from there I think you'll be able to do the rest. So solve this graphically. We could solve this based on what we did yesterday very easily. We could say, well, the quantity inside of here is either going to be 3 or negative 3. Again, x minus 4 could be 3 or it could be negative 3. So before we can do it graphically, let's solve it algebraically to verify that our answer will be right after. So this quantity, x minus 4, it could be 3 or x minus 4 could be negative 3. Because we know that whatever's in here, again, when you take its absolute value to make it become 3, means it's either 3 to start with or it's negative 3. So our answers are just going to be x equals 7 or x equals 1. Now, that's algebraically, but I'm just putting this on the side. That's a positive one, by the way. Equals. Okay? That's our algebraic solution. Now what I'm going to show you today is how to solve this graphically. It's actually a lot easier graphically. So, here's what I want to think. I want to translate this statement above into like a sentence, okay? From an equation back to a sentence. As opposed to when you did word problems, you translated from a sentence to an equation. Okay, you're given a paragraph, and you need to write equations, now we're going to work backwards. Okay? So, here's what I think. Remember this before on the last slide? It was like a minus b, like that. We looked at that quantity, and we said it was the distance between a and b. So this tells me that the distance between some value x and 4 is going to be 3. Again, the distance between some value x and 4 is going to be 3. So let's start by putting a 4 out here as our starting point. And it'll work. You'll see what I'm saying. Start by putting a 4 there. Now, some quantity x, which is our solution, we know is going to be a distance of 3 units away. What's 3 units to the right on the graph? If I make this my starting point, let's call this my starting point, go 3 units to the right. What do you get to? Everybody? Go 3 units to the left. What do you get to? Look at your answers. 1 and 7. What do we get as our answers, guys? 1 and 7. So this method is a little bit easier. It's not an algebraic solution, it's a graphical solution. We're going to do problems that are more complicated than this basic one here, but the general idea is the same. So our solution set is just 1 and 7. So again, in your equation, here's what I want you to do. Write some notes down. This, 4, I'm putting an arrow for the 4, please. It's all up on the screen. This is your starting point. Again, this value here, whatever this turns out to be, is your starting point. Assuming it's negative, obviously, it's got to be negative. If it's not negative, we'll put minus the negative, and you'll see that. This will be your distance, or your, I'm going to call it my deviation. And the reason I'm calling it a deviation, there's an I in there. There you go. D-E-V-I-A-T-I-O-N. The deviation in math, anybody know what deviation means? What's a deviation? Never heard it before? if everybody in the class hypothetically got a 70 on a test, and one student had like a 75, there would be a 5-point deviation from the norm in a sense. Okay, deviation, what is different from the norm. So I'm going to call this my deviation, my movement from left to right. And then x is just the value you're searching for. So you don't need to put anything here. If you want to, you can just put solution, that's what you're looking for. But it doesn't matter.
What would happen if you have an absolute value on both sides of the equation?
On both sides?
Yeah.
We wouldn't be able to use the graphical method. We'd have to go back to algebraic. But we're not going to get into that just because, honestly, it's not seen widely and it's not even used in calculus. You don't have absolute values on both sides unless they're the same term. Remember in the homework you had like 4 absolute value of m, and the other side there was 3 absolute value of m, so you can combine like terms. It's rare to non-existent that you have absolute value of 2 different arguments. Like if you had absolute value of x plus 5, and on this side absolute value of 2x minus 7, like those are different terms. It doesn't come up often, and it was, yesterday I was tempted to do it at the end of class, but with the time and with the difficulty of yesterday's class, I didn't go on to that. I'm not going to. I can show you guys that we have more time another day for sure. It's just a little bit different style, that's all. It's not difficult, but it's just another type of equation. But again, it does not show up often. Okay? It does not show up often. And what I'm trying to do is prep you guys for calculus, really. So I taught calculus in my last related calculus, so I know what you need to know for calculus, and that's never going to come up in one of those exams. Okay? So I'm trying to make it feasible, and we're going to optimize the time you have together. All right, let's take a look at number 2. Now, number 2 is no different from number 1, except that we have a less than or equal to sign now. Again, no different from number 1, we have a less than or equal to. What did I say should be in between here, though? A minus, but we see a plus, don't we? Does somebody want to tell me, how can I rewrite this so I see a minus sign?
Make 3 negative.
What is it?
Make 3 negative.
Well done, Erickson. Oops, we close that with the parentheses. Okay, again, rewrite it such that you have a minus sign in the middle. So how would you do that? Minus a negative is really a positive. Okay, very good. So what's my starting point, everybody? Nick, what's my starting point? Negative 3, good. Okay? Katerina, what's my deviation? 5. So I started the starting point here. What do I do?
You're going to go 5 to the right.
Yeah. And?
Then 5 to the left.
Good. So going 5 from the right, what do I get? What's the point going to be?
2.
And left?
Negative 8.
Okay. Next, we have to figure out if this is an and or an or statement now, don't we? Want to finish it?
No, I actually have a question.
Okay.
For the first example, we started on 4, not -4. Why?
Because the first one was y minus 4. Whatever is here is your starting point. This happens to be y minus negative 3. So whatever is here is your starting point. The last one, if you remember, x or y, whatever it was, looked like this. Okay? So 4, the number 4 was your starting point. Whereas here it's negative 3. Okay? Anybody know how to find out what this is? Is this a left? Is this a, are we going to shade in between? So we're going to have clearly, we're going to have one of our closed circles here and one of them here. Am I shading between them or going away from them? And how or why? What's one way to test things? Some? Yeah, check one of the numbers in between in the original, always. So if you want to try it, I'll explain another way to do it, but isn't 0 in here somewhere? Isn't 0 always an easy number to test? If I plug in a 0, what does this become? Plus 3. Is 3 less than 5? So you shade in between. The region in between is the solution. Try a number on the outside. Anywhere, and this is a good calculus thing you're learning right now. You do this all the time in calculus, using number lines to test what are called derivatives. So you have to remember this when you get there. If you test the number on the outside, what's going to happen? 10, okay? 10 plus 3? Is 13 less than 5? No. So outside the region will not work. Okay? These are in calculus, we call these locations here critical points. And they're critical points because they're either my endpoints of a solution or they're the beginning of 2 or statements. The beginning of 2 or statements. Now, another way to remember this. to know that it's going to be shaded in between. Take a look at your less than or equal to sign. If you had said a statement like this, right? Imagine the statement was like this. Replace whatever's in the left-hand side. We call this, by the way, the argument. Y plus 3 is the argument. Replace the argument with simply x. If you saw this statement, it would tell you that the absolute value of x has to be less than or equal to 5. To graph that, you would say, well, it's everything between -5 and 5. So you have a solution set that goes in between -5 and 5. Same thing, except now it's not -5 and 5, it's -8 and 2. Correct. So if you plug in a number on the outside of the two dots and it didn't work, you shade in between. If you plug in a number in between and it doesn't work, you're going to shade on the outside. Okay? Again, though, it is good to know that this here, and remember, means this. Okay, that's what that means right there. So remembering this simple rule from yesterday's class might help you remember that it's the points in between. The points in between. Questions on this one? How would I write the solution set to this in set notation? Or regular, it's fine.
-5 is less than or equal to
This one.
-8 is less than or equal to x, which is less than or equal to 2.
Okay, good. It's y. Nothing matters really, right? That's fine. We'll just be consistent. Now, in set notation, you just put the y in the front with a colon, and you put your set, which did not look like a set. No, sorry. You want these sets, right? That's the open. And that's the close. Okay? Again, open set, y, colon, lower bound, y, upper bound, closed set, or closed bracket. All right? Questions? Okay. All right, next one. Next one's a little bit tricky. The next two are kind of tricky both, actually. Now, start by looking at this equation first, and notice that there's some differences in the argument. And again, the argument is this quantity on the inside of the absolute value. If we look at the argument here, we're going to notice right away that we don't have x minus some number. Now we have some number minus x. Does everybody see that right away? Last time we had a variable minus a number. Now we have a number minus a variable. Can somebody give me a suggestion as to what we can do here? Why can we just switch the order? You're correct. Why are we not to just do that in this problem? Good. If you switch the order of a subtraction problem, it just becomes the opposite, right? 5 minus 2, 2 minus 5. One of them is 3, the other is -3. If you switch the order and it's in the absolute value, it doesn't matter. It's the same thing. Is anybody else getting hot? I see him still going like this back there, and I'm like sweating up here. Just for a little while. Just a little while. We'll go back off for again. Well, I could do that, but I'm wear all this shirt. Starting Monday, right? Everybody remember that? Don't forget. Starting Monday, blazers and shirt and tie. Whole different story. You gotta make sure you have that every day. Are bow ties cool? I think they are. Okay. Oh, they're cool. For sure. I have a bow tie. I haven't worn it. Let's see.
I like those. They're cool.
They are cool. Good stuff to tie. Have you ever tied a bow tie?
Yeah, I had time.
You know what I'm talking about?
It took me hours to
If you don't know how to tie a bow tie and you have a smartphone, you can download the app. It actually teaches you how to tie a bow tie. I downloaded it one time. All right. So, as Alejandro said, let's start by rewriting. 2r minus 7, okay, instead. Because again, it's the same thing. And we know this from our old notes from chapter 1 that said this. Okay, we went over that one quickly in chapter 1. That was one of the ones that we kind of like flew through. The quantities don't matter when you switch them, as long as it's in the absolute value. All right. Next, if I continue this process, this is not going to give me the answer for r. Remember, this was remember this here was like my starting point, and this was my deviation, and this was the solution. So if I do this process, it's going to give me the solution, but the solution for 2r, not for r. And we want to know what is r. Everybody see what I'm saying? Okay. So somebody else tell me what I can do now to avoid that 2 or get rid of that problem. Yeah, so we're factor it out. Very good. So let's do this. Let's write this line as 2 parentheses, r minus 7 over 2 greater than 5. And you're going to see why I'm doing this right now. If you were to distribute this back out, try it yourself. 2 times r is 2r. 2 times 7 over 2 is just back to 7. Everybody see that? Whenever you factor out a number that's in front of the coefficient, just make that the denominator in the other part. Okay? So if this had been a 3, if this had been a 3 right here, this would have been a 3 right there. Okay? It's a little like quick trick to know, but it does really help a lot. Now, what was my other rule for absolute values? With products of absolute values. Who remembers that? For example, if I said to you, what can I write that instead of? Instead of absolute value 2 times absolute value 3, what can I write it as?
Absolute value.
Yeah, my rule was that, and if you remember the rule, it was the absolute value of A times the absolute value of B is equal to the absolute value of AB. You can tell a product inside of here. What's wrong? Too much? It's funny, I kind of want to laugh too. The absolute value of a product can be written as the absolute value or the product of 2 absolute values. So see how this is written separately and then it's written together? Take a look over here. These are written together. Write them separately. What is so funny? They're all smiling now.
Maybe something stupid that my daughter was trying.
Okay, never mind. So, rewrite this as 2 separate absolute values. You see the 2 here and the quantity r minus 7 halves, break them up separately. Because now, what's the absolute value of 2? Everybody, what's the absolute value of 2? It's 2, right? So you can simplify this now. I'm going to scroll down for more room. Give me a sec. So at this point, write this as follows. 2 times absolute value of r. What's 7 over 2, by the way, as a decimal to make this easier? 3.5, good. Okay? Now how do I get rid of that 2 in the front, everybody? What operation? Division, good, or divide. Divide by 2, divide by 2. What's 5 over 2? As a decimal, sorry. Okay, yeah, 2.5. Now, take a look. Now it's easy to solve, because look, here is my starting point, and here is my deviation. So the only difficult part about this kind of a problem is that you need to manipulate or alter the expression that you started with. Once you get into this form, then at that point, you're able to then just solve or write graphically. So graphically speaking, who wants to come up and show me what this answer would look like? Here, come on up.
Okay, oh, actually,
You can do it, Peter. Come on, I'll do it.
well, I mean, it's not quite done yet. I just like, right?
Start with what you
So,
start
do
with.
we have to add this?
This is what we start with.
Oh, yeah, yeah.
This is called deviation.
Alright, okay. So, for 1, right? Okay, 2.5. Okay, okay.
So there's our starting point at 3.5. Good.
2.5.
And how much do we deviate left and right?
2.5 weeks.
Okay. So add 2.5 to the right. Good. What do you get to? You have 3.5 and 2.5. 6. Good. And when you subtract 2.5 from 3.5, what do you get to? 1.
Alright, so, and then, that's it, right?
So far, so good. Yeah. Now the question becomes this, guys. We want to know what values can go in here. These are my critical points, 1 and 6, right? I want to know, am I going to go that way, or am I going to go this way in shape?
I'm guessing you know that way because the previous one.
Yeah, I knew you were going to say that. I knew it too. Well, that's why we put together, right? So this many things we're looking for. He's right. Let's give another reason, though. With reasoning, people. Summer.
Because say 0 doesn't work on the inside.
Yeah, that's another way to check. Plug in 0, everybody. Oh, actually, no, wait. Plug in 0's out here,
I
somewhere.
mean, 2.
Okay. Plug in 2, as someone said. Plug in 2. 2 minus 3.5. Negative 1.5. Is 1.5 greater than 2.5?
No.
No. So since the middle part didn't work, we put an open circle here, and here it can go outward.
Okay.
Okay? Well done. Thank you very much. Okay. Again, another way to remember, here's another way to remember in case you like rules. There's a simple rule. When you see it greater than, and you have the variable on the left and the number on the right, it's always going to go outward. If you see this as a less than, it's going to go inward. Does that make sense? Again, if it's in this setup with the variable here and the number over here, if you see a greater than, go out. If you see a less than, move in.
You also have to remember this way, greater and great for
Oh,
and
I like that. He said greater than, and he said greater as greater than. Or, the word or, he's thinking of it as in the word greater. You know, it's greater. I like it. Whatever works to make you remember, right? It's called the mnemonic. Anything that works.
Yeah, that's like I still don't know the difference between the signs unless I like picture like
An
my,
alligator.
yeah, an alligator eating the bigger number. My
See,
brother
I-
told me that when I was a third.
Yeah.
I never got that.
My teacher used to literally go like this.
Yeah, I draw
She
teeth.
would draw like teeth there and a little eye right there.
Yeah, because I still don't know what
Just
it
eat
is
there,
unless
too.
I think about
I
it.
never got the alligator.
I just do Pac-Man.
Pac-Man, all right. Pac-Man does do that. You're right. That's true. All right, one more. Might finish a little early today. All right. This one looks tricky, but it's not. And I want you to think about C and B as if they were numbers and what you can do. Try it on your own. I know it's going to sound weird. Think of C and B as if they were numbers and try and graph it on a number line, but you're going to have an answer with C's and B's in them instead of numbers. Yes. Your answer will have C's and B's in there. By the way, the last one, in case you're wondering, the last one, the solution set, written in set notation, would have been this. Okay, that was from the last problem right there. That would have been the solution set. Let me know when you're right up. Come on. Good. Now writing the solution set. Very good. Right with set notation. Good. Now write it in the solution set form. Someone knows a minus sign? That's what it's taking, right? Look up here. answer? Well, take a look. Your starting point is C. Your deviation is B. So you start at C. If you want to go to the right by B units, you take whatever C is and you add the quantity B to it. If you want to go to the left by D units, you take whatever C is and subtract B from it. Now, we see the less than sign, right? See the less than sign. Here you can't really test points, right? Doesn't work too well. So you have to remember less than is our and statement here. Oops, not closed circle, open circle. So, Jules, tell me, what would my solution set look like for this one?
It's going to be x colon c minus b is less than x, which is less than c plus b.
Awesome. Okay, again, we're going from C minus B through X all the way to C plus B. That's how we think about this. These are our anchors. From here to here, we know that these are the answers. We have a less than sign in both spots, so we have an open circle on our number line. Any questions on this problem? This one's a trickier one, okay, but I think today's lesson was easier than yesterday's lesson. Okay? Homework. Section 2.5, I'll put it up, but I know some people are still copying. Section 2.5, 3 through 30, there's multiples of 3 though, multiples of 3. What else is due on Monday, people?
Problem set.
Good, problem set number 2. Please don't forget. Remember, if you're working together, I want to see both names on every page, and etc. You saw those guidelines I gave you. If you need a template to see the guidelines, where can you find my template? Go to Moodle, with problem set, you see my solution to the first one. Okay, we got a minute or two. What time's the bell ring today? 21, right?
No, 30.
Hey, yesterday was 29 because we had an exam.